Hi, my name is Jessica Perez, and today I'll be explaining Chapter 5, Problem 83 from the text. The question states both pulleys are fixed to the shaft, and as the shaft turns with a constant angular velocity, the power of pulley A is transmitted to pulley B. Determine the horizontal tension T in the belt on pulley B, and the X, Y, and Z components of the reaction at the journey bearing C and thrust bearing D if theta equals 0. The bearings are in proper alignment and exert only force reactions on the shaft. So first, what we have to do is identify our givens, and we're given that force 1 equals 50 newtons, force 2 equals 65 newtons, force 3 equals 80 newtons, the diameter of A equals 80 millimeters, the diameter of B is 150 millimeters, and the length of the total side is 750 millimeters. That then brings us to step 2, which is to determine what we need to find, and we need to determine the horizontal tension T and the X, Y, and Z components of the reaction at bearing C and the thrust of bearing D if theta equals 0. That means we have to make assumptions, and we can assume that this is at equilibrium. Pulleys are at a fixed position and move with a constant angular velocity, and the bearings exert a force only on the shaft. Step 4 would be then to make a plan. So step 1 would be to find the moment of X by setting it equal to 0 in order to solve for the tension. Step 2 would be to find the moment about Y and Z components at C to find the reactions at this bearing. And it's on the x-axis, so you don't need the x component. Then step 3, the last step, would be to solve for bearing D by finding the force at the X, Y, and Z components and setting that equal to 0. Step 5 is to make a free body diagram, and in my free body diagram I converted the units. So in the picture we were given, the units are in millimeters, however I converted everything to meters, and then I added the components at C and D. So the components at C is CZ and CY, and then DX, DY, and DZ are also there. And yeah, so then that brings us to step 6, which is the solution step. So you set the moment of X equal to 0, and that would be 65, the force times the diameter, minus 80 times the diameter as well, plus tension times diameter minus the force times the diameter, which equals 0, and that gives us the tension to equal 58.0 newtons. Then we find the moment about Y, and you would do 65 plus 80 times 0.45 minus CZ times 0.75, and that results us with CZ equaling 85 newtons. And then you do the moment of Z equals 0, so you do 50 plus 58.0 times 0.2 minus CY times 0.75 equals 0, and CY equals 28.8 newtons. And there you would have the tension, and you have the bearings at C. Then you need to solve for the bearing of D, so you would do the force of X and the Y and Z components equal to 0. So because it's on the x-axis already, D of X equals 0. Then we move on to D of Y, setting that equal to 0. So you do D of Y plus 28.8 minus 50 minus 58.0 equals 0, and dy equals 79.2 newtons. And then you would do F of Z equals 0, so dz plus 87.0 plus 80 minus 65 equals 0, and that results us with 58 newtons at dz. And that completes how solving this problem. Thank you for following along, and have a nice day.